All right, 3.7, sinusoidal function context and data modeling. Here we go.
In previous units, we have looked at different methods to construct models for various functions. Now we will apply those same techniques to create function models for sinusoidal functions. We have already seen that sinusoidal functions can be written in the form f of theta equals a sine, in parentheses b, in parentheses theta plus c, close parentheses plus d, or in similar form with cosine. To construct a model, we will need to contain information that is given verbally, graphically, numerically, and algebraic to properties of sinusoidal function graph.
Fantastic. All right, so let's look at example 1. We've done these a lot. What's the period of this function? How long did it take to complete its cycle? 2. All right, so the period there is 2. All right, fantastic. All right, let's keep going. All right, so example 2. So now we have a cosine function, it says, and we need to figure out what is c. So where does sine start? Sine starts at like 0 usually, right? And then it goes which way? Up, right? And where does sine usually reach its maximum? Pi over 2. Okay, we set both of those equal to pi over 2 today. So our maximum's at pi over 2. Now, where does cosine start? It starts at its maximum, right? And so our t value of our maximum is going to be what? 0. Our input value on cosine for its maximum is what? 0. In sine, it's usually what? Pi over 2. But in this one, we're going to set it equal to 0. All right, and so let's do it. We usually set it equal to pi over 2 for a sine, but this one's going to be a cosine. So we're going to set it equal to 0. And then it's set equal to this 2 times x. Well, where did we reach its maximum on this one? Where did we reach its maximum? It's either here or here. Where did we reach a maximum at? Pi over 2. Let's put it there. And so remember, we're going to set in pi over 2 plus c. Now, how do we solve for c? We divide by 2, right? And so we divide 0 by 2, which is still what? 0. And so now we have 0 is equal to pi over 2 plus c. Well, what's c? Negative pi over 2. And so I look for that answer, and is it there? No, it's not there. Okay, and so they had to use a period on this one. And so what's the period of this? Pi. All right, and so I can add or subtract pi all I want, and I should get out to my same spot. And so when I add pi to this, what do we get? We get pi over 2. And so that aligns with c. Remember we did those like tables, and it said like f of 9, and f of 9 was not actually on the table, but it said like the period is 4. And so we had to use those periods. It's going to be the same thing, except this one was a period of pi. Now, if we actually chose negative pi over 2, and substituted that in right there, guess what we would have gotten for c right away? Pi over 2. But did we have to? No, but we had to understand our periods. All right, so I'm kind of glad you didn't.
A yo-yo that is attached to a 30-inch long string is rotated at a constant rate. The figure provides a representation of the yo-yo in the xy plane with the direction of rotation indicated. At time t equals 0 seconds, the yo-yo begins to rotate. The yo-yo is at the start position in the figure. At time t equals 5 seconds, the yo-yo has completed 20 rotations, and the yo-yo is in the same position as it was at time t equals 0.
Love it.
A sinusoidal function is used to model the x-coordinate of the position of the yo-yo as a function of time t in seconds. Which of the following functions is an appropriate model for this situation?
All right, fantastic. So on this one, again, let's look at our choices real quick. So they're all sine, which is great. But then what do we notice about our amplitude? They're all what? 30, okay? And so that's why it's because this is a 30-inch long string. All right, so our amplitude is 30. Now, what's different about all of them? My b is different, which means I need to solve for our what? Our period, okay? And so what is my period? It took 5 seconds to go around 20 times, or it went around 20 times in 5 seconds. So what's my period? How long did it take to go around once then? 1/4. So my period is 1/4. And so what's my normal period of sine? 2 pi. And so I take 2 pi and divide it by b, which would be equal to what in this case? 1/4. And so now I multiply by b, I divide by 1/4. Well, dividing by 1/4 is really multiplying by how much? 4. And so what is my b here? 8 pi. And so which one corresponds with that? D. All right. And so there is my b.
The clock is mounted on the wall, and the point P is located at the tip of the minute hand of the clock. The function h represents the height of the point P from the ground at time t, where h of t equals a sine b of t plus c plus d. In the xy plane, the points h of 0 equals 70 and h of 30 equals 52 represent the maximum value and the minimum value, respectively, on the graph of h. What are the values of a and d?
All right, so what does A represent? The amplitude, and D represents our what? Our midline. So let's start out with our midline. I think that makes more sense. So how do we get to our midline?
Add both, subtract by 2, or divide by
Divide by 2. So we find the average of them. So what's 70 plus 52 over 2? What's 70 plus 52? 122 divided by 2 is 61. So my midline is y equals 61, right, Aiden? All right, and so my D is 61. And so now let's find my amplitude. And so what's my amplitude on this? 9. Okay, it's the distance away from our max and our min. So that's all we had to solve for on that one. All right, keep going.
The average monthly temperature in degrees Fahrenheit for a town in central Indiana can be modeled by the sinusoidal function. T of m is equal to 25.7 sine of pi over 6, n minus 4 plus 61.2, where m is less than or equal to m, and m is less than or equal to 12 months. Based on the model, which of the following is true?
All right, let's just break it down for just a sec. All right, and so what's my amplitude? 25.7. So what's my midline? 61.2. All right, now where does a normal sine function have its maximum? At pi over 2, right? And so where does a normal sine function have its minimum? 3 pi over 2. And if I used a period, it would also be negative pi over 2. Does everybody agree with that? And so it would be 3 pi over 2, negative pi over 2, 7 pi over 2, and so forth. But anyway, that's what would happen. So let's look at A. It says the maximum is 61.2. Is the maximum 61.2? No, that's in the middle. All right, and so that's not my maximum. I'd have to add 25.7 to that 61.2. Make sense? So that's why that one's not it. So then let's look at part B. It says the maximum occurs at m equals 1. Well, let's see what happens. When I substitute in 1 here, I'd get 1 minus 4, which is how much? Negative 3, right? And so now negative 3 times pi over 6 is what? What? Negative pi over 2. It's negative 3 pi over 6, which is negative pi over 2. So at negative pi over 2, does that happen at a maximum or a minimum? A minimum. So a minimum is going to occur at m equals 1. All right. Did you catch that? All right, cool. And so now let's keep going. So now it's asking for a minimum is 35.5. Is that true? So I take 61.2 and subtract 25.7. Do I get 35.5? Shall do. We do. All right. Now let's look at part D. Let's just look at part D to make sense of it. So a minimum is going to occur at m equals 7. So if we substitute in 7, what would we get? 3. 3 times pi over 6 is what? Pi over 2. What's happening at pi over 2 for a sine function? A maximum. This is saying a minimum.
Okay, the function n gives the number of nighttime hours on the first day of a given month, where 1 is less than or equal to t, which is less than or equal to 12. The table gives values of a and at selected values of t. A sinusoidal regression y equals a sine of b t plus c plus d. With 12 iterations is used to model these data. What is the maximum number of nighttime hours predicted by the sinusoidal function model?
All right, beautiful. And so this is going to be a regression model. And so what do we need to do for our regression model? Get out our calculator and then go to stat and then what?
trace.
Not yet. Stat, edit. So we put it into stat, edit, and then what do? We go to stat, and then calc, and then what? Sine regression. All right, so once we got to sin regressions, all right, sine regressions, now we have that. And so then how do we actually get to our max? We take our what? Our midline, and what do we add to it? Our amplitude. And so we're having this 8.2153 plus this 3.1175, and so they rounded. So what do we end up getting? 11. All right. So there we go. On this one, what would my normal period of sine and cosine be? My normal period's what? 2 pi. But if I had to find the period of this, what would I take 2 pi and do with? I take 2 pi and then divide it by what? My b. All right? And that would help give me my period of this function. Okay? So sometimes they might ask something like that.